I have to differentiate sine inverse of 2x upon 1 plus x squared. Y is equal to sine inverse 2x upon 1 plus x squared. Guys, if you conventionally differentiate it, it's going to be a very, very painful affair. You'll have to consider this to be sine inverse of a function of x, do chain rule, that will work out to 1 by root of 1 minus fx square into derivative of x. It's going to be painful. So let's use our inverse trigonometric knowledge, the basic one we have. Let's use our trigonometric knowledge and try and really simplify this and make life easy for you and me. So essentially, I know that sine inverse of any sine theta or sine of any function is theta or that function. So somewhere, if I can make this to be sine of some value, my life becomes much easier. Does this resemble some form of sine? Does me taking x will help me convert it into some form of sine? I know for a fact that sine of 2 theta is equal to, yes, the one we've used traditionally, the one we've used more often is 2 sine theta cos theta, but sine 2 theta is also equal to 2 tan theta upon 1 plus tan square theta. So, is there a case for me to consider the x within the sine inverse as tan theta? Let's see if it helps. Let x be tan of theta. So what happens within my function? Y is equal to sine inverse 2 tan theta upon 1 plus tan square theta. Can I write, now that I've assumed x to be tan theta, can I, and now within the sine inverse I have 2 tan theta upon 1 plus tan square theta. Can I write y is equal to sine inverse of, I can replace this by sine of 2 theta because this resembles sine of 2 theta. Of course, it is because of my assumption x is equal to tan theta. So y is equal to sine inverse of sine 2 theta. Sine inverse of sine of anything is really that thing. In this case theta, or it could be any function, or it could be anything. Sine inverse of sine of something is that something. So here too, sine inverse of sine of something will work out to that thing. Y is equal to 2 theta. However, this is not an acceptable end to the problem. A, because I want to find dy by dx, and B, my problem was all about y and x, and it still has to be about y and x. What did I assume x to be? I assumed tan theta to be equal to x. So, what is my theta here? It is nothing but tan inverse x. To just brush your memory, we just saw on the earlier slide, if tan theta is equal to 1 by root 3, tan theta is equal to tan pi by 6, theta is equal to pi by 6. However, I can also say tan theta is equal to 1 by root 3, theta is equal to tan of 1 by root 3, theta is equal to pi by 6. Theta becomes inverse of that trigonometric ratio on the right hand side along with the value. So our value is x, unknown value. Theta becomes tan inverse of x. Substituting this theta in the y I have here, y is equal to 2 theta. So y becomes 2 tan inverse x. Now, with respect to this, in comparison to this is much easier to differentiate. Now I can say, taking ddx of y is equal to ddx of 2 tan inverse x. I can take out the constant outside the derivative. Dy by dx is equal to 2 into derivative of tan inverse of x. Dy by dx is equal to 2 into, I just saw in my formulas earlier, ddx of tan inverse x is equal to 1 by 1 plus x square. So this becomes 1 upon 1 plus So that's what the sum is.